Hey guys, today we're going through another LeetCode question in a mock interview style. So the question is number 36, valid Sudoku. So determine if a Sudoku is valid according to the rules, and the Sudoku board can be partially filled where empty cells are filled with a period. So to further explain how Sudoku works, each row must contain the numbers 1 to 9 occurring just once, each column must contain the numbers 1 to 9 occurring just once, and the numbers 1 to 9 must occur just once in each of the 9 sub-boxes of the grid. As always, I encourage you to pause the video here and try and solve the problem on your own first. So the first step is to always ask some clarifying questions from your interviewer. For example, can the input be empty or invalid? How are empty cells dealt with? Etc. Since this is a LeetCode question, this will not be helpful, but in an actual interview it is essential to ask these questions. Now, many of these problems are actually brain teasers that you'd easily be able to solve by hand if you forget about the code. So that's where I always start. So my first thought was, we can just iterate through each number on the board and see if it's valid. So for example, if I look at the 5 in the top left corner here, we want to check if there's a 5 anywhere down here, anywhere across, or a 5 anywhere in this top square. Now, since there are no other 5s, here, or here, we know that this 5 is a valid number. And then my thought was we would just move on to the 3 and we would repeat this process. So you can see the pattern here. We're checking if the number already exists in the row, column, or square. If there's a duplicate, it's an invalid Sudoku board. So we're going to need to create some structures to keep track of what numbers we've seen in each row, column, and square. Let's just start with rows as an example. So let's say we were looking to track the first row. We could do this in binary quite effectively, where a 0 means the number is not in a row and a 1 means the number is in the row. So I'm just going to write that out. Okay, perfect. So I'll just write out an example here. So we know there's going to be 9 numbers in a row. So if we had 9 zeros, and we had them all in a row like that, that means that we have no numbers in the row. Now, what happens if we had 8 zeros, like so, but we had a 1 at the end? That means that we have an existing 1 in the row. In the same way, if we had 1, 0, 0, 0 here, it means that we have a 9 in the row. And if we had something like a 1 at the end and a 1 at the beginning, that means that we have a 1 and 9 in the row. So each of these could be represented by a short or an int for this number right here. So we're going to go with shorts for this example. Since we have 9 rows, we're going to need 9 shorts representing each row. So we need essentially a short array to keep track of what numbers are filled in each row. And we can do the same thing for columns and squares, have short arrays for each. So in this way, we're going to basically have these 3 arrays that keep track of what numbers we've seen in each row, each column, and each square so far. So now that we've sort of fleshed out our solution in our heads, we can start coding. Okay, so I've set up a main function here with the array from the question, and we're just going to call our function on this array and print out the results. So let me just run that, and you can see we're currently getting false because we haven't implemented this function. So the first thing we want to do is create the short arrays we talked about. So let's just go ahead and add those in. So we're going to create one for our rows, our columns, and our squares. So we're going to say short rows equals new short, and since we know that each row contains 9 numbers, we can just say 9 there. And we're going to repeat this. So we're going to do short calls equals new short 9, and then short squares equals new short 9. Okay, Perfect. Now, the next thing we want to do is we want to iterate over the board. And the first thing I'm going to recommend with this is it's much better to name your variables something like row and call so you don't get confused. Using I and j can be confusing for both you and for your interviewer. So let's create our for loops here. So we're going to say for int row equals 0, row is less than the board length, row plus plus. So now we're iterating through all of our rows, and now we need to go through our columns. So for int call equals 0, call is less than board 0 dot length, call plus plus. Okay, so now we know that we're successfully iterating through all of the numbers in our board. So the first thing we need to check is if a square on the board is blank, because if it's empty, we don't need to worry about it. It's already valid, so we can continue. So we're just going to put in here if board at the row and column we're currently on is equal to the period as specified in the question, then we're just going to continue. Nothing to worry about there. Okay, so next we need to get the short value of the board character. So I'm just going to write out this code and then we'll talk about it. So I'm going to say short value equals short 1 shifted by board row call minus 1. Okay, so we say board row call minus 1. And the reason we do this is because if we had, let's say we had the character 1, for example. So if we had 1 minus 1, it would equal 0. And if we had the character 2 minus 1, it would equal 1. So we're basically getting a value here. So from our value, we're then going to shift a 1 left that number of times. So for example, if we had the value 1, what we're expecting to get as our value here is we want to get 8 zeros and a 1 at the end, right? So when we do board row call minus 1, so we take 1 minus 1 and we get 0, we're shifting a 1 left 0 spots, so we do indeed get this number. Alternatively, if we had a 2 there, so we did the character 2 minus the character 1, we would get the value 1, and then we'd shift that, so then we'd shift the 1 left by that number of places. So in this case, we're shifting 1 left by 1 time. And so then we'd get the following. And that's exactly what we're looking for. So this one here, this value would symbolize that we have a value of 1. The 1 being here symbolizes we have a value of 2. And you can play around with this and make sure you fully understand it and see for yourself a little bit what I'm talking about here. So if we take this value, I'm just going to remove these comments. So if we take this value and we AND it with our current row and it's a 1, it means we've already seen this number in a different row. It's a duplicate, so we know that it's a bad value. So that's exactly what we're going to do. So we're going to say if value ANDed with our rows at our current row, if that value is greater than 0, we're going to return false. So we're just saying if we take a value and we AND it with our rows, and so we know that a 1 and a 1 will return a 1, right? And anything else will return a 0. So if we've already seen a 1 there and now our value's a 1 there, that means we have a duplicate value, so we have to return false. And we're going to repeat this process for columns as well and for squares. So if value ANDed with calls our column, our current column, if that's greater than 0, we're going to return false. And now we're going to do it for our squares. So this one's a little different. Again, I'm just going to write out the code and I'll walk you through it. So if value ANDed with our squares at 3 times the row over 3 plus the call over 3, if that value is greater than 0, we're going to return false. Okay, so that's a lot. Let's go through why this is the case, because this is the most tricky case of the three. So if we're in row 0, 1, or 2, we know we must be in one of the top 3 squares. So we divide the row by 3, giving us 0, and add the column over 3. So let me just write out some examples to showcase this. So let's say we had, I don't know, row equals 0, and our column equals 0. So based on this expression we've just written out, we would have 3 times 0 over 3 plus 0 over 3, which would equal square 0. And that's correct, because if we're in the top left corner, we are in square 0. Now, what about the case where we had our row equal to 2 and our column equal to 0 again? So we know that if our row equals 2, so we're into basically our third row of our Sudoku in the 0th column, we know that we're still in that same square. So we should get square 0 again. And let's see if that works out. So we have 3 times 2 over 3 plus 0 over 3. And that's correct. We still get square 0. And 2 over 3, of course, becomes 0 because it rounds down. So this is all looking good so far. Now, what about the case where we were in a really high column? So let's say we were in row equals 0 and column equals 9. So in this case, we're at the far right of the Sudoku. So we're going to be in square 2. So we do 3 times 0 over 3, which is going to turn out to be 0, plus 9 over 3, right? Or sorry, not 9 over 3. It's the 8th index. And that's going to equal square 2. Okay, perfect. So the code is working great so far. Now, if we were in row 4, we would either be in square 3, 4, or 5. So let's see if the code reflects that. So if we have row equals 4 and call equals 0, we would have 3 times 4 over 3 plus 0 over 3, which is going to work out to square 3, which is perfect. So again, you can walk through the math and ensure you understand that, but you can see that this code is basically saying, let's just find out if in our current square, whether that value already exists. And if it already exists and we have a duplicate, we're going to return false. So, perfect. I think you get the idea here. So now, if we haven't seen a duplicate value, this is a good number, but we need to update our row, columns, and squares for future iterations. So how do we update a binary number? We use OR. So we're just going to add that all in right here. So we're going to say our rows at row, and we're just going to do OR equals value. So we've just updated our row to include that value. That way, when we AND it with future values of that row, we're going to be able to get a value greater than 0 and be able to return false. So let's also do the same for our columns. So calls call equals value. And of course, we also need to do it for our squares. So we get our squares indexed the same way we did above. So we're going to say 3 times row over 3 plus call over 3 or equal value. Okay, perfect. Now, if we go through the whole board and we see no problems, we know it's valid and it is safe now to return true. So at this point, we're just going to change that to true. All right, so let's try running this. And you can see we get true for the example Sudoku board, so we know that this is working correctly. So the first question you're probably going to be asked is, what is the big O of your solution? So we have two for loops, and because of that we know it's O(n) squared. So the question is this a good solution? And the answer is yes, because in order to check if the board's valid, we're going to have to touch on every number at least once in the board, and that's what we've done. So this is perfectly fine that it's an O(n) squared solution. Okay, so now let's talk about some test cases we may want to run through. These will be based on how your interviewer answered some of your clarifying questions. And here are some basic ideas. So you would probably want to check if the input is invalid, if your code still works. You'd want to check if your code handles the case where there's a duplicate value, if your code handles a valid Sudoku properly, etc. For these, just walk through your code with an example and make sure your code still works. And if your code failed any of your test cases, think carefully about how you can revise your solution to address it. Well, that's it. I'll put up the solution on GitHub for anyone to download and review, and please leave comments if you see any errors, think you have a better solution, or if you solve this in a different language and think it might be helpful for the community. And be sure to subscribe if you want to see when I put out new videos so you can solve these problems right along with me. Good luck with your interview practice!